Page 399 of your texts gives you a nice box summarizing all of the rules of logs we've seen so far. So we had the first 4 rules in the last section, and then we added the product rule, the quotient rule, and the power rule in this section. Now, if you just look at this and try to just memorize the rules, it's easy for this to start looking like gibberish and for you to mismemorize and misapply the rules later on. Okay, any of the rules by themselves, totally fine. You could memorize it, you could work with it. But when you've got all of these rules, it's really easy to get overwhelmed. As we worked through these, we always talked about why they were true. And the key to all of these is that log means exponent. So if you remember that, so that you can have some understanding of the rules. I'm not saying don't be familiar enough with them that you sort of, just instinctively say, oh, multiplying, I want to add. I'm not against you trying to have the rules memorized. I'm against you doing a blind memorization. I want you to try to understand why they work. Okay? So here, the log base b of 1 is 0. If I rewrite that in exponential form, that says b to the 0 is 1. That's my familiar rule that anything to the 0 power is 1. Log base b of b is 1. If I rewrite that in exponential form, I get b to the first equals b. That's my familiar rule that anything to the first power is itself. Okay. Rules 3 and 4, we said these were the facts that log functions and exponential functions are inverses. So here, I'm taking an exponential function with base b. I'm plugging that into the log function base b. They're inverses. The log function undoes the exponentiation and gives me back my input. Here, I'm composing the same functions, but in the opposite order. I'm taking the log function with base b. I'm plugging that in as my input to the exponential function. The exponential function undoes the log function and gives me back my initial input. Okay. And then these are the rules that we had in this section. Log means exponent. So the one log, or the one exponent for a product, is the sum of the logs, or the sum of the exponents for the individual factors. This is the quotient rule. One log, or one exponent for a quotient, is the difference of the logs, or the difference of the exponents for the top and the bottom of that fraction. And then this rule, this corresponded to our power to a power rule. This, I think, is the one where it's the hardest to actually see the connection, although if you recognize that's an exponent, you can see, and that's an exponent, because log means exponent, but I can see these are exponents with different bases, because this is base b, this is base x, but we are multiplying those exponents. So this came to us from our power to a power rule. Okay, so these are all rules that you want to be familiar with. There is one more rule that's given in this section, and it's the change of base formula. And there's not a whole lot of homework, and I actually didn't assign any in this, but you're going to want to know that this formula is out there because you may need it in future classes. It's one that I don't have memorized. I'm going to just show you how I would use it. Let's say I had the log base 3 of, let's just say 25, okay? And I want to evaluate that, okay? Well, 25 is not a nice power of 3, so I'm not going to have a nice way of just rewriting this and evaluating it by inspection. I'm going to need some technology, but my calculator does not have a log base 3 key, okay? So here's what I would do. I would give it a name. I'm going to call it x, and so I can now rearrange things as I'm used to. So 3 is my base, 25 is my result, the log or the exponent is x. Okay. All right, so I've got this. Now, if I want to be able to plug things into my calculator, I need to work with either the common log or the natural log, because those are the keys that all calculators have. So what I'm going to do is I'm just going to take the natural log of both sides. I'm going to say the natural log of 3 to the x is equal to the natural log of 25. Keeping in mind that x is the thing that I'm trying to figure out what it is. X is my original log base 3 of 25. Well, now I can use my power rule and I can say x natural log of 3 is equal to the natural log of 25. If I wanted to solve for x, I would just divide both sides by the natural log of 3. So x is the natural log of 25 divided by the natural log of 3. So what I get is a quotient of logs. Now remember, we have no way of simplifying this. I would have to just plug in to my calculator, which I can do. Let's do it. Natural log of 25 divided by natural log of 3. And I get about 2.93, just rounding to the hundredths place. Okay, so there was no way I was going to get that by inspection because I don't know what 3 to the 2.93 is off the top of my head. Okay. Makes sense to me that it's a little bit smaller than 3 because 3 cubed would have given me 27 and 25 is a little bit smaller. Okay. But that allowed me to get things in terms of a base so that I could use my calculator. Okay. Like I said, I don't have the change of base formula memorized because I would just always do this and solve for things. But notice essentially what we said. We said the log base 3 of 25 was the natural log of 25, which is the log base e, over the natural log of 3. So as a general rule, if I have the log base b of a and I want to change to a different base, let's just say I wanted to switch to a base. Let's call this B1. That's my first base. Let's switch to base 2. Okay. It would be the log base 2 of A over the log base 2 of base 1. Okay. I end up evaluating the log of that argument with the new base and dividing by the log with the new base of the old base. Okay. Again, you should know that that formula exists because there may be times, particularly in future classes, where you need to change the base for something. But we're not going to be using that a whole lot this semester, so I haven't assigned anything on that. I wanted to show it to you. You should know it exists. You're not going to be responsible for it. You will be responsible for solving equations like this, but that's what we're going to be doing in the next section.